then why we should choose Raman? And nowadays people are telling that Raman is easy tool compared to that of X-ray. Then what are the benefits or what are the advantages of Raman over these X-ray diffractions, or how we can compare this X-ray diffraction with Raman?
Yeah. So let us make a see. We always have a complementary technique, and we always have a technique which is having advantages and disadvantages. For example, if you compare a Raman with X-ray diffraction, it's only for a suitable for a very like ordered crystal. Most of the materials are solid, but as I already said in my PPT, like it's a known information. Raman is independent of matter, independent of wavelength. But whereas X-ray, you have to send it only in X-ray wavelength, and your matter should be in a solid form. This is the most interesting thing you can think. Also, the another thing is that Raman, there is not much sample preparation or something like that. Even though it's a sample independent, you have some vial or any kind of sample platform you can put and you can get it easily. But Raman also very sensitive for a lighter molecules, but X-ray is not very sensitive for a light because it's a diffraction based principle and diffraction coming from the outer electrons. So for a lighter element already having a lesser electron, you will not get the diffraction process correctly, and you will not be able to characterize the very like a hydrogen and other light elements. Those are the very few examples which can directly illustrate that Raman is much more better. But obviously, in some context we cannot use Raman, and we can use X-ray also. But especially the interesting like people are interested in now like a layered material, not like a three-dimensional van der Waals layer system, and graphene and graphene based and hydrogen based. So nowadays people are interested in room temperature superconductors, hydrogen systems. All are very sensitive for a Raman measurement and very easy also. And also Raman spectrometer, it's not like if you use a visible radiation, you can portable, you can bring from one place to another place. But X-ray radiation and all, you need to have a proper X-ray source, and the laboratory should be highly shielded for X-ray detection. You cannot like what I'm trying to say, certain kind of radiation toxicity problem also is there in X-ray diffraction, but scientifically we can do. But what I'm trying to say, for a more common people, if you use a visible radiation as a excitation source, it's like a more user friendly. And interpretation also, X-ray, if your crystal structure, it is a very, very complicated. You have a triclinic structure, it's very difficult to identify, like almost like not possible. Yeah, because like a very least symmetry will have a large number of peaks. But Raman, if you have a like log books, certain are already reported, or you have first principle calculation, quite easy to do the identification of the structure. That's why many biological people are interested in using a Raman, like a drug protein interaction and all, studying the Raman and Raman based technique.
Okay, thank you, Rajaji. And one more thing, the feedback link is shared in the chat box as well as our webinar group, WhatsApp group. Please fill up that feedback links for your attendance. And one more question is appeared in the chat box. Will this technique be useful for quasi-crystals?
Yeah, the quasi-crystal is a very interesting topic, because quasi-crystal was actually discovered in Banaras in the university. But the quasi-crystal is a five-fold symmetry exists. Like a different symmetry exists than the already known phase group. So people thought that it's a wrong crystal, which we analyzed wrong. So we missed one Nobel Prize. And quasi-crystal is very interesting. Otherwise, India would have got second Nobel Prize in science. But the main question is quasi-crystal. Yes, people are really using quasi-crystal for a supersymmetry, for a Raman, and you will get not like a first order Raman. What I mean to say is, you have a crystal. If you have a quasi-crystal, like a symmetry is not represented by regular phase group, so you will get an additional peak like a zone folded mode, like a coupled mode. Those things can be used. Obviously, we can use to characterize a Raman, because it will give information about your bonding. It will give information. Definitely, it will be useful. But quasi-crystal research as such, people are doing very less, and understanding this is very, very, very complex.
Dr. Rajaji, I have one more question. Actually, if I have an unknown sample, I have taken X-ray, and there will be a GCPD's data that I can compare and find out which one is that sample. Exactly, we can find out. But is there any possibility in Raman like that? Most of the people will ask, sir, if I am doing Raman, I will get a spectra, and how I will conclude or how I will understand the exact material, what it is, how we can do that things in terms of Raman spectroscopy. Is there any easier way to understand that?
Yeah, so first of all, I somewhere some PhD colloquium I saw that there is a 3 lakhs of materials are man-made, like a commercially made, like a human-made materials. So you have to have a lot of database. If you fingerprint, then you can match it. People are interested in now organic molecule. There is a STBS database is there. You can check ethanol, methanol, so standard samples. But in general, the question is, if the unknown sample is given, you can record a Raman. If it's a Raman active, you will get the peak. If you have a log, you can match it. Like JCPDS you have, we have a SDBS, or you have to have the literature. You completely do not have any idea, then you have to do elemental identification by a method called like a energy dispersive spectrum. Like it will tell elemental XPS. It will give the what is elemental present in the system. For example, you have a salt. You have a system of salt. Let's say salt is giving a Raman spectrum, but you don't know. But if you go on to do the EDS, then you will get the sodium and chlorine with the, both are 1:1 ratio. Then obviously this is a sodium chloride. Your system should be a sodium chloride. And then if you have then the strategy like a CAD kind of thing, it will be reduced. But frankly speaking, if you only given a one sample which you don't know absolutely nothing about the Raman, then it's a very tedious process. But if you take a Raman is active, you couple with the EDS, you will almost like a very close to 60-70%. But nowadays people are interested in some, for example, like a more clustering, like a very different amorphous, different polymorph. That time we have to couple more than EDX, very specific techniques. But it is possible to do for a simpler system, already known system, at least coupling with one more technique. But completely no information, it will be difficult for anyone. But I have done one exercise using a Raman. I was actually given in a titanium oxide, a white powder. We did a Raman. We do not have any much understanding. Then we did a EDEX, which is telling titanium and oxygen present in the system, like a 1:2 ratio. Then we got to know titanium oxide. There is a titanium oxide, 3 kinds of phases are there: anetyl, brutase, and rutile. So then we compared the 3 phases. 3 are having a different symmetry, and one symmetry is matches with us. So we identified our unknown sample. This was an exercise also we have done like in 2013.
So what I have understood means if we get a clearly pure unknown sample means we should do a set of experiment or set
Yes,
of
set of experiments.
Set of experiments, and Raman will give its own importance informations through in that set
Yeah.
of experiments.
For example, if you are asking the question, let us reverse in a very scientific scenario. I have given a MOS to layer material. Then, or I have given a graphene, let's say graphene, carbon. Then it's very difficult to say right. Even you go the X-ray, it will not show any periodicity in the system. It is very weak scattered, for example, graphene and all. That time, if you take a RAM and G and 2D band, directly will tell. It's about but it is correct that we have to couple with other technique to certainly say what is it.
Okay. Is there any questions? Other questions? Any doubts? You can ask. I am repeating again. We may not get a chance like this again and again. So if you have whether it is a symbol or no need to try anything, you can shoot it. We can clarify it now itself. Please ask the questions if you have. Sir, okay, if one person want to study Raman, and do you have any better reference to give them? Means somebody wants to know a good reference for reference book or something like that. Then you please share. Then they can go through that in their own way.
Okay.
So anyway, okay, now it's 11:54. I think we can conclude the sessions. I think so. Anyway, first of all, I am very thanks. Okay.
I invite Dr. Now, all are will the feedback. Thank you. Over to Dr. Shiva.
Okay. Anyway, as a part of our today's National Science Day celebration program, today Govt Polytechnic College organized an international seminar on Raman effects and its spectroscopic applications by Dr. Rajaji Vincent, postdoctoral fellow, Harvard University, USA. As at the end part of this first day, and it's my duty to deliver a vote of thanks to one and all. First, I would like to thank our beloved principal in charge, Mr. Pradeep M, for his overall support and encouragement for conducting this program fruitfully. I also extend my sincere thanks to Dr. Anil Kumar C, Senior Scientist, KSCST Perinthalmanna, for his cordial association with our program and for inaugurating our today's National Science Day celebration programs. And it is the time to thank our eminent speaker, Dr. Rajaji Vincent, for his marvelous talk on Raman effect and his spectroscopic applications. Actually, me and Rajaji both joined at IGCAR Kalpakam in the same batch, but he moved to Jain Caesar. 1 year we were together, studied for our coursework and all at IGCAR. Still I am remembering each and every day. Even in the midnight we were studied for I get a pass mark in mathematical physics and all. Still I am remembering. Okay, leave it. But he moved to Jain Caesar, Bangalore. After completing his PhD, now he is joined as a postdoctoral fellow at Harvard University, USA. Ultimately, so he is always very close to me. That time, from that time itself, and I extend my sincere gratitude and thanks in the name of Govt Polytechnic College and our team to him. Thank you, Rajaji. Thank you very much. Moreover, it is the time to thank our audience, teachers, and students from various institutions for their kind attentions and cooperations in our small program. And in the same occasion, just I want to give a hint for the tomorrow's program that there will be a science quiz program. Tomorrow there will be a science quiz program in the same online platform basis. There will be 30 questions. It will start at 10:30 a.m. sharply and at 12:30 a.m. And audio means a video I have shared in our group. Through that video, you can learn how that quiz program will happen. You can join the program at any time in between 9:30 and 12:30. The candidate who are securing above some cutoff mark will be getting a participation certificate. The winners, first to second and third position, will be decided with respect to the mark as well as how quickly they are answering the questions. So the way of answering question is also important. Anyway, best wishes to all of them. And once again, thank you for one and all for making this program as a grand success, especially for Rajaji. I am repeating again, is one of my closest friend, and I want to carry this friendship throughout my life. And I feel again I will ask your help for this kind of situations, irrespective of your busy and tight schedules. You should come and participate for common people. We are common people, so if you, whether you are in a good institute or good position, whatever it may be your position, you should come and cooperate with us. That's my request. And thank you, Rajaji, once again. Thank you.
Thank you all.
Thank you. Thank you.
Thank you. Thank you, Dr. Shivdas. Thank you, Dr. Rajaji. Here comes an end to our first day program. We will join you tomorrow for our quiz. Thank you all. Have a good day.
Thank you once again. And this quiz link for the quiz I will be shared in tomorrow 10:30 itself. So best wishes for all the students participants. Thank you. Thank you. And this is the end of the section. This is the end of the session. Okay. Bye. Bye.